Hello and welcome to part 2. So we're picking up with question 3. Now question 3 is really exciting because it's a binomial multiplied by a binomial. So think back to Algebra 1. This is where your teacher might have said something like FOIL, or they might have just said the distributive property, or they might have talked about using the box method. So I'm going to work out both here, but I'm only going to work out one of those methods in question 3 because question 4, question 5, and question 6 are all great examples of a binomial multiplied by a binomial. And so I'm going to switch back and forth between just doing the distribution and doing the box method. But ladies and gentlemen, if you like foiling, I'm going to tell you right now that that's technically a shortcut. And so I'm not actually going to directly talk about that. But if you're comfortable with foiling, please foil away the evil one's master plans. Let's go ahead and talk about question 3. Question 3, we are multiplying here between x plus 5 and x minus 7 because there's no symbol there. But with that x plus 5 and x minus 7, because we're multiplying, the x is being distributed to both the other x and the negative 7, and the 5 is being distributed to the x and the negative 7. So for question 3, I'm going to model this using the box. Dun, dun, dun. Normally we like thinking outside of the box, but don't worry, we will be thinking outside of the box in this problem as well. So the box, ladies and gentlemen, if you're unfamiliar with what the box is a graphic. It's a graphic organizer. Oop, no, thank you, sticky keys. It's a graphic organizer about an area problem. We know how to find the area of a square because it's length times width. Notice the key word there was times, multiplication. We're multiplying x plus 5 and x minus 7. So we could find an area of a box treating x plus 5 as the length and x minus 7 as the width. And so, just like length and width, we're going to write the x plus 5 on one side as a label and the x minus 7 on the other side as a label. And so in order to find the area inside, I'm just going to be multiplying. But notice on how I wrote it. I wrote it specifically lined up with the box so that we can focus each term one by one. And so let's go ahead and multiply down. X times x, well, we know that's going to be x squared. Then we have our x times positive 5, which we know is going to be 5x. Negative 7 times our x. So notice what I'm doing is I'm looking at the columns and the rows. Negative 7 times our x in this spot right here is negative 7x. And last but not least, our two regular numbers, negative 7 and the positive 5 multiplied here is just negative 35. For our last term. And so what did we just do? We multiplied our lengths and our widths together to get these four numbers. Well, what do we do with those now? Well, we find the area by just adding all of them up. But they're not all like terms, so they're not just all getting shoved together at once. We're just adding together what we can. And so our x squared, there are no other like terms with x squared. And so x squared just gets to hang out by itself. Bam. But our two x's, 5x and negative 7x, do combine because they are indeed like terms. And then our negative 35 here at the end doesn't have any other like terms with it. So let's actually combine our like terms. Negative 7 plus 5 is negative 2. The x is still there because that's our label. So we have x squared minus 2x minus 35. And that's the answer we're looking for here. That's what we get from multiplying our two binomials together. And let me just check which of those match up here. Oh, bam! Option 2. Sweet success. So, ladies and gentlemen, let's do the same thing with question 4, but rather than using the box method as a graphic organizer, let's just multiply with distribution. And so, on question 4, we have our 2x minus 3 and x plus 6. 2x minus 3 and x plus 6. So first, just as an aside, because of the fact that the 2x minus 3 is being subtracted and the x plus 3 is being added, we do indeed need the parentheses around both factors here. We need the parenthesis around the 2x minus 3, and we need the parentheses around the x plus 6, because both of them need to be grouped together separately in order for this multiplication to pan out. And so we're going to go ahead and do our 2x multiplied by x, distributing just the 2x to the x, and then the 2x to the 6. But then each term in that first set of parentheses is being distributed to every other term in the other set of parentheses. So the negative 3 is also being distributed to the x, and to the positive 6. And so we are doing that distribution for both the 2x and the negative 3. So let's do the 2x first. First, 2x times x is just 2x squared, multiplying 2x and x together. Then 2x times 6 is going to be positive 12x. And now let's do the multiplication for our negative 3. Negative 3 times x is negative 3x, and negative 3 times 6 is negative 18. And from there, we actually focus on combining our like terms, which in this case is just the 12x and the negative 3. 12x minus 3 is 9x. We're still working with our negative 18. That had no other like terms. And we're still working with our positive 2x squared, because there were no other like terms there either. So we have 2x squared plus 9x minus 18 as our new trinomial that came from our multiplied binomials. All right, making sure it actually matched up. Whoa, success! There it is, option 2. Let me draw my circle a little bit nicer there. Awesome. So, ladies and gentlemen, you have successfully seen the box method and just regular old distribution played out in order to get those actually multiplied together. Now, when you look at questions 5 and when you look at question 6, they are the exact same process. And so, if you feel comfortable doing that multiplication, you can go ahead and end the video here, actually multiply it together, you're going to be in great shape. But I'm going to go ahead and kind of breeze through question 5 and question 6 just to give you that extra bit of practice. And so, let's go ahead and multiply our 3x minus 7 with our 2x minus 9. And so, doing that multiplication, I'm going to go ahead and just distribute 3x times 2x, 3x times negative 9, and negative 7 times 2x, and negative 7 times negative 9. So 3x times 2x is 6x squared. 3x times negative 9 is negative 27x. Negative 7 times 2x is negative 14x. And negative 7 times negative 9, well, negative times a negative is a positive. 7 times 9 is 63. Alas, alack, good news. We just need to add, I guess in this case, subtract our like terms. So negative 27 minus 14. Oh goodness, I'm on a video. I don't want to get this wrong. So let me use my handy dandy calculator, and not just any calculator, but the Desmos calculator. Boom! All right, guys. So what was I doing? I was doing negative 27 minus 14. Negative 27 minus 14 is negative 41. Whew, I'm so glad I didn't try to guess on that one. That would have been really embarrassing if I got 13 as a result. So let's go ahead and do negative 41x plus 63 with our 6x squared right here in front. And ladies and gentlemen, 6x squared minus 41x plus 63 is right there. Let's go ahead and model question 6. And as I promised, we're going to use the box method to model this one. And so, using the box, aren't my sound effects the best? So, let's go ahead and layer them out. So I'm going to go ahead and color code this. First one purple and the second one blue, just to help keep our colors organized. It does not matter where you put the x minus 4. It could go on top or it could go on the side. Either one works because multiplication can happen in any order. And so I'm going to go ahead and write x minus 4 right here. I'm going to go ahead and write x plus 4 up here. And then we're going to do some multiplication. And so x times x is x squared. X times negative 4 is negative 4x. Positive 4 times x is positive 4x. And positive 4 times negative 4 is negative 16. Ladies and gentlemen, when you put all this together, you get x squared minus 4x plus 4x minus 16. And then we combine our like terms and look at this special. Right here, actually, what color do I want to use? I'm so excited, I'm going to use orange. Negative 4 plus 4 cancel out. Addition undoes subtraction. That gets a 0. And so really, all we're working with is x squared minus 16. And ladies and gentlemen, it may not mean a whole lot right now, but it may be something that you remember from previous years. This is called a difference of squares. Why? Because subtraction means difference, x is squared, and 16 is 4 squared. So when we have the difference of squares, that's really special because we know we're just subtracting 4 and adding 4 with our original binomial multiplication. So that's a really fun and special pattern that you'll see pop up again and again as you guys go forward. Good news is, though, x squared minus 16 is the one we're looking for. So, ladies and gentlemen, we'll pick up with question number 7 in the next video. Thank you guys for your time and your work. See you soon.